Okay, so it looks like you've got you're fine with this, and then I think where you're following down it looks like is this. So I know that the sine is 1/2, and I can go at a decimal number with my calculator, but it's also I know that the 30-degree angle has a sine that's 1/2 because it's half the hypotenuse, right? So pi over 6. And then in order to get back to that angle, because they're looking for we're looking for the four smallest solutions. So that means we had to go with just the two more than the two common ones. So the two positive ones. So to get back here, we go all the way around 2 pi, and then we could keep going around however many times you want to go around. So that's like that all solution kind of idea, right? And that's why I wrote the k. And then there's another angle that has that same sine of 1/2, and that's over here in quadrant 2. And the reference angle is also pi over 6, or 30 degrees. So to get this green angle, it's pi minus the reference angle. So that's where I wrote 5 pi over 6. And again, to get back there, you go all the way around again and again and again. Okay, so 2 pi. And that's equal to your pi over 5 times x. So now we're going to solve this equation. So what that means, I'm going to multiply by 5 over pi, or divide by pi over 5, right? And each of these things in here gets multiplied by 5 over pi, which makes that, if you think about this one, pi over 6 times 5 over pi. The pi's cancel out, so I'm left with 5 over 6. And then here, the 2 pi, so 2 pi k times 5 over pi, the pi's cancel out, and so that leaves me 10k. And so that's going to be a series of answers that will help us get the 4. And then for this other one, again, we're going to multiply by 5 over pi. There the pi's cancel out, so I've got 25 over 6, and then I get another plus 10k. So how do I get the 4 smallest answers? Well, the smallest answer is going to be pi over 6. I'm sorry, it's going to be 5, 6. That's the first one. See, the period, this changes the period of the sine function. So we can't just say pi over 6 and then what, 12 pi or 13 pi over 6, etc. It's because the period changes to 10. So the first answer is 5 pi over 6. The second answer becomes 25 over 6. And then to get the next answer, so I got here, let me come up here. So I got 5 over 6. I got 25 over 6. And then I'm going to add 10 to this. And I don't have a calculator on me, so I'm not going to count the actual decimal values. And then the next one will be the 25 over 6 plus 10. And that's how you do it. Okay. Now you could cheat. I mean, it's important to know how to do it this way. I mean, if you're not going to do calculus, not so important. But if you're going to go on Calc 1, Calc 2, you kind of got to be able to think that way. You could just throw it in a graphing calculator. Here, let's just a minute. Let me show you what happens in Desmos. Okay, so you see, well, pi over or 5, 6 is 8.833, and then to get the next, and no, remember how I said plus 10? Well, there's the next one, so that's actually the third one. And here's what 5, 6 or 25 over 6 is, and we're going to add 10 to that. And there's the next. See how that's working with knowing how the periods work. So I mean, I'd hate to see you solve these this way, because if it's on a test, I'm going to have to dock some points. But this is a good way to check it, check how you're doing that. And go back each you do. You can try in the textbook. I know you guys run short on time, but in section 6.4, is it? Maybe it's 7.1. Let's see. It must be in 7.1. No, here it is. Here it is. It's like question number 33, 34, 35. They're asking for the first two positive solutions, but try treating it like you had to find 3 or 4. Okay, so hopefully that helps.